everyone. Welcome to this ISG Smart Talk. Today, we will be discussing edge computing enabled by 5G. Before I hand things over to our presenters, I quickly want to run through just a few reminders with you. We are recording this webinar, and you can access the replay using the same link you used to register for this event. Also, you can submit any questions to our presenters by using the Ask a Question box on the left side of your screen. With that, I will now hand things off to David Lesson to kick off today's webinar.
Thank you, Jillian. As mentioned, my name is Dave Lesson. I have 20 years experience in telecommunications and information technology, and I'm going to be leading the webinar today on edge computing enabled by 5G and a reality check and implications for business-driven IT. We're going to cover real-time campus networks, global campus networking trends, is 5G a game changer, the organization of your private campus network, and the bottom line take-home message summary. And we're going to dive right in to global campus networking trends. I'm going to take a moment to introduce those that are also presenting today. So, Henning, would you like to introduce yourself?
Yes, thank you very much. My name is Henning Dransfeld. I'm with ISG for 6 years now, since being acquired through Experton. I've been in research for 20 years, and I'm covering the aspects of business models, applications with regards to particularly manufacturing.
Thank
Over
you,
to Swati.
Thank you, Henning. Hi, I'm Swati. I have about 6+ years of experience in the telecom domain, and I have been with ISG for 2+ years, and I am currently with the network operations and research team. Over to you, Titli.
Hello, everyone. Thanks, Swati. So this is Titli Chatterjee, and I've been in research and consulting for over now 12 years. And in ISG, I am leading the research initiatives of smart manufacturing vertical. So over to you, David, to take us through to 5G landscape.
Thank you, Titli. And we apologize for all the canines in the background. There's only so much we can do to eliminate the outside world. All right, global campusing networks. What are the stakes? 5G brings significantly new capabilities and features that can add considerable value into your manufacturing, retail, and other closed perimeter environments such as a warehouse, or even in some cases, a mining operation that has a fixed perimeter. Investing in your campus network can enable real-time interactions and machine-to-machine communications in 5G, but in communications. But is 5G at this stage of maturity the best choice for you and your organization? Massive machine-type communications enables the connectivity of large number of sensors and devices that aren't available in today's mobile generations. So 2G, 3G, 4G, they're all very good networks, but they cannot support the number of devices we're talking about in a global campus, in a campus environment. Nor can it support location precision, which is something, a new feature that 5G brings to the table, and significantly enhancing the precision of where a sensor, a device that's being monitored, where it is at. Also, which is, we're headed toward industry, we're in Industry 4.0. As this location precision, it continues to improve, we do expect this will be leveraged in Industry 5.0, which is the interaction between man and machine, or humans and machines. One of the concerns, and this is something that the network operations and team spends a lot of time on, is whether or not your IoT device fleet, which is leveraging 2G or 3G or even 4G today, it may be at risk of being sunset. As 5G is being deployed, spectrum is being reharvested and networks are being mothballed or shut down. Some networks, this has already happened to. ISG does maintain a database in over 200 countries, over 800 mobile operators, and the mobile operator networks, and we can help you plan for your the obsolescence of your current IoT fleet. Oops. Sorry, clicked on the wrong slide. Swati, could you describe the current 5G deployment and future 5G?
Absolutely, David. Thank you. So what is the most exciting thing about 5G? For me, it is network slicing, because today, if I have to download a movie and also watch a high quality video, I get affected by poor performance. But when there is network slicing, I have a separate channel to download a movie, another channel to actually watch a live match, and well, another channel where I can email my boss calling in sick. Well, jokes apart, let's take a reality check of how the 5G deployment has fared. So ISG has a global mobile network database, and we have used this to figure out that about 30% of the operators worldwide have active commercial 5G networks deployed. About 61 countries worldwide have commercial 5G networks deployed according to data by GSA. Now, there are two types of 5G network that is available. One is 5G in standalone mode, and the other is 5G in non-standalone mode. Non-standalone mode uses existing 4G core and 4G or 5G radio to give you the true 5G-like capabilities, whereas 5G standalone mode uses 5G core and 5G radio, which is actually the true 5G. So using the current network, how do we get 5G-like experience? The answer is edge computing. We will get into edge computing soon in the future slides, but what edge computing has done is it is enabling operators to test waters in over-the-top solutions before 5G is completely deployed or in some cases even available. Release 16 of 5G has enhancements in user equipment, power saving, MIMO, beamforming, positioning, etc. But what release 17 brings to the table is that it enhances existing features in live 5G networks for use cases in automotive, logistics, media and manufacturing, and public safety verticals, leading to a more ubiquitously connected environment. This is something that we should all be excited about. And to get into a bit more of specificity of the use cases, I would like to hand it over to Henning.
Thank you, Swati.
Thank you, Swati. Thank you, David. So let's have a look at the possible applications. I mean, on the top spot on this chart, you see something called a tactile internet, the possibility of having immediate access at very high bandwidth with much lower latency than what we're used to today, enabling applications such as telemedicine or car-to-car connection. You might ask, why are we talking about such an application so far out today? Well, the two big advantages or expectations which come with 5G are increasing bandwidth requirements from under 1 megabit per second to over 1 gigabit per second on the one axis, and on the other axis you have lower latency requirements. Why do you need that? We have certain applications like the eCall button, which is being introduced in all European cars now to call it automatically for assistance when you have a breakdown. That's an application which certainly requires very low latency. If you're looking for disaster alerts, the latency has to be even lower. On the other hand, we've seen through the pandemic last year that the cloud-based office has become a reality for most of us today. The cloud-based office requires far more bandwidth than the scenarios we were comfortable with so far. So between those extremes for high bandwidth and low latency, there's a lot of applications we're using today or we're developing to use in the near future. Virtual reality, augmented reality are integrated in manufacturing increasingly now with a lot of steps which are being taken today. They have to become more powerful. The constraint is often the bandwidth required for applications going as fast as we can develop them. So looking at the mix like video calling, where you need several participants, that's something we do now. But we do it every day in our work. So the requirements for 5G on both axes is actually accelerated by the need for making these applications work and improving on them going forward to differentiate our product offering, to differentiate the way we work, to differentiate ourselves, getting closer to the customers and their expectations, but also differentiating from the competition, which is not sleeping either. Back to you, David.
Thanks, Henning. One of the areas that Swati alluded to earlier was that not all spectrum types, or 5G networks are going to be available. With only 69 mobile operators, or 29% of operators having deployed a 5G Release 16 network, not all features and functionality are going to be available. And Swati, I was hoping you could describe some of the what is available today, some of the spectrum and features.
Sure, David. So 5G spectrum has 3 bands. One is the low band, which is currently used for our 2G, 3G, and 4G. The second is mid band, and the third is high band. So as we go up, the frequency increases. So mid band and high band is where the 5G pulp resides. So higher the frequency, we get higher bandwidth, which will result in higher throughputs. But there is a downside to it. As we go higher in frequency, the penetration and coverage decreases. So how do we cope up with this? One way is to combine it with the existing lower band using dynamic spectrum sharing and use that for coverage, and use the mid band or the high band, which is really limited at present as we see, to use it for higher throughput applications. The second way to use that is to deploy multiple network components like picocells, femtocells, repeaters, in effect, small cells along with your macro sites to increase coverage. But this will give rise to a more heterogeneous network and also lead to network densification. That is something that we have to do as we move from 5G to possibly 6G. So what are the 3 main important things in 5G? The 3 cases are throughput, high reliability and low latency, and connection to massive number of devices. The traditional use case model creates an expectation that all 3 use cases will be commercially available as soon as 5G is deployed. But that is not the case today. A more realistic timeline would be to deploy and develop these use cases in a staggered manner. 5G has huge capex investments, and pandemic has escalated the financial woes for operators. So the operators will increase investments, implementations, and innovations only when they see a positive business impact. So use cases like MMTC and URLCC will not be possible without a wider 5G coverage. So that would mean more and more 5G implementation. as a consumer, if I have a 5G site next to me, I can experience the high throughput capabilities. But in order to implement or use these use cases like MMTC and URLCC, we, at least at present, what we see is it is a possibility in only a private campus network. However, I would like to point out that the key expectation of 5G is to enable new capabilities and tap into more new opportunities using these use cases. As 5G matures, MMTC and URLCC will be pretty common, but at present, it is exclusively for private campus networks.
I want to emphasize that for our viewers. For the 5G in your pocket, the mobile phone that you're looking to buy or have already acquired, that is going to support enhanced mobile broadband. But the features for IoT, Internet of Things or industrial Internet of Things, that is going to require the sophistication of Release 16 and Release 17 of 5G, which again is coming in hopefully in July or June or July of this year, was delayed, if you will, due to the pandemic. So we're already running 6 to 8 months behind, but we're catching up. But because the emphasis for the carrier is to get a return on investment for all the spectrum that they just acquired and will continue to acquire, especially in the high frequency spectrum, edge computing is going to be what's driving the use of 5G networks within a campus. And that is because cloud is no longer viewed as an operating model. It's it's viewed as an operating model. It's not viewed as a place anymore. Workloads need to be run where they're going to work the best for the desired work, the function it's supposed to deliver. So many workloads which do require low latency and a combination of 5G and edge computing is going to be necessary. Some workloads, such as a streaming service, it offers backhaul from a centralized cloud to the edge. That's going to improve customer service as well. And I'm going to turn it back to Swati to talk about latency of the various iterations. Swati?
Sure, David, thank you. So what we see here is that data volume versus a latency plot. So in case of a 4G network, which is predominant in most of the countries now, the data moves from the user device to the left hand of your screen to the data center, which is the centralized cloud. So the latency is about 100 milliseconds. But when edge computing is used, the data has to flow from the user device to the edge cloud, reducing the latency to almost a 5G-like timing. So the latency is about 30 to 50 milliseconds, which is pretty much close to what we get in 5G, that is about 20 milliseconds. The advantage, again, that 5G brings is that it has higher bandwidth capabilities. So a large amount of data can flow through 5G either to the edge or to the data center, which improves workloads such as streaming devices, or it could be in case of smart factories. Basically, it depends on where you want your workload to run. If you have some emergency or mission critical applications, it is better to use the closest edge location or have an on-premise data center. But in case your application is not so latency driven, then you could use a centralized cloud. But what 5G brings to the table is that it allows large volume of data to flow through. Over to you, David. Thank you.
Thank you, Swati. All right. So now we know that 5G, while it's not hype, it's not absolutely ready in real time the way some applications would require use. And that would be the distributed edge. And that represents what we all use and enjoy today. But the features that we have available to us on 4G really aren't going to be able to support all of the sensors and types of features that are really only available in 5G mobile operators. So the distributed edge is really going to represent the traditional hyperscaler environment or system integrator environment where the applications have been built. They already use mobile cell phones, but that's going to be limited to 2G, 3G, 4G, depending on the country of operation. The new world is going to be the dedicated edge, or at least, for the near foreseeable future, the private network, as Swati had mentioned. And that's going to be carrier provided and managed spectrum with going to deliver the cloud computing experience. And this is what's different on your private hardware and mobile stack. And there are a number of different ways to get to a dedicated edge. One way is to acquire your own spectrum. You could literally, when a country runs an auction, you can bid on it. Another and easier way is to use a license or shared spectrum that's provided by the operator or system integrator. And then finally, there's a new service availability is using unlicensed spectrum, meaning consumer broadcast radio spectrum, which is being opened up in countries all over the globe. One thing we included here, just to give you an idea, is different countries and regions that have set up some, auctioned off spectrum to a private enterprise or to a government agency to allow them to run these 5G private networks. For now, I'm going to turn it over to Titley to talk about the early deployments and what we're seeing in private campus networks. Titley?
Thanks, David. Thanks, Swati and Henning, for taking through the 5G spectrum, the landscape. It helps me to understand 5G better and from a manufacturing perspective as well. So talking about the 5G implications across sectors, it can be a never-ending one because there are a lot of sectors, for example, in warehouses, the online retailers and warehouse operators deploying robotic production or product tracking or the IoT warehouse applications driven by 5G, or if we look at the utility sector, the combination of private LTE and 5G networks enabling utilities to more easily and affordably connect their IoT applications. Now, if I can keep talking about the various role it plays across verticals or across a value chain. Like, for example, again, in mining, oil and gas, the convergence of private LTE and 5G networks, what it does and what it brings to the table for mining and energy extraction is indeed plays a significant role. But then having said that, amongst all these use cases, early deployments show that manufacturing is the low-hanging fruit and it leads the pack. Now, while I talk about the implications of 5G in the manufacturing perspective, it is indeed a vast area. You keep reading, experiencing, and witnessing this sector. So instead of giving a futuristic view on the manufacturing paradigm, I would rather see the immediate issue the industry is facing. Especially, it's a no-brainer that especially post-COVID, everyone would want to understand the speculations and where it is leading to. Now, the different industry challenges like high precision, even in fast and complex production processes, machine-to-machine communication, identifying faults at the shop floor, coordinating mobile transportation systems, huge amounts of data transfer, etc., etc. And it's here where the question arises, can 5G be a solution? So perhaps this is the reason why we are over here today talking about the various aspects or facets of 5G. Now, over here, when we see this particular industrial automation pyramid, it is a very a traditional automation pyramid comprising of the equipment and process control, as well as the sensors, the data collection, that is the industrial devices. But that is not the bottom line of the slide. I would rather talk about what is happening and where are we moving from the state-of-the-art factory, which was probably yesterday, and how are we moving towards factory of future. So I will not talk much about the state-of-the-art factory. What happened yesterday, every one of us might be knowing in the manufacturing sector. But then in the factories of future, it is a transition from segmented network design or siloed toward a fully connected one. So we are moving towards a single source of truth.
Just Titli, one question on the future smart manufacturing.
Yes.
Intel has just made the announcement yesterday that they're going to spend $10 billion on building out a new high-tech chip chip plant in the United States, in Arizona. That means
yes.
they're taking a lot of the production back in-house. It also means that they're building up a new plant in a high-cost country, high-cost labor country. Presumably, that's going to be planned to be very smart.
Absolutely. And this is one of the examples that you said, Henning, is a classic example of, again, product optimization. And I'm sure somewhere or the other, the network will come into picture. So having said that, while we are moving towards the factories of the future, as I was talking about the connectivity that implies both horizontal and vertical integration across all layers of the automation pyramid. So previously it was moving in silos, and now it would be an integration driven by industrial 5G. And apart from all this, 5G allowing campus networks eventually will drive industrial IoT, which a lot of companies, a lot of manufacturing providers, companies are thinking of implementing, irrespective of a small size company or a mid-size company. So again, if I talk about manufacturing, I can keep talking about the various implications and the aspects that is happening right now. And over here, I would rather emphasize on the 5G features and the differentiators. Now, all this while, we have been talking about the various band spectrums and the bandwidth and what are the, how is 5G playing a role across verticals. Now, 5G's technical capabilities in driving smart manufacturing adoption is beyond throughput, I would say. It's various features like latency, device density, implication of network slicing that my colleague Swati was talking about all this while, will have a significant influence on the manufacturing sector. Now, if I talk about the ultra-reliable, low-latency communication platform, talk about the URLLC, what was happening is, all this while, the cloud-based computing was all good, unless it had certain use cases, like a self-driving car, which can't afford to wait for several milliseconds for the cloud to analyze its sensor data, go back, analyze its sensor data, and then tell it to stop as and when required. Perhaps on a lighter note, by that time, the driver would have definitely taken a stance. So over here, I would say the data needs to get analyzed at the edge. So where is the edge fitting in over here? And edge plus 5G, how will it drive the manufacturing value chain? Now, the business critical data can be processed at the edge data center, while more long-term processing needs can be anytime pushed to another facility further away. And having said that, talking about the IoT devices, now it is no stranger that today IoT has had a massive impact on the manufacturing sector. Enabling instant anywhere access to content, I would say, is no longer a competitive advantage for companies. It should be part of the best practices. However, as IoT connects larger user bases across geographically dispersed markets, ability of the network to guarantee that there is no randomness and that an event will not occur in a specified predictable time. That is, it would be neither faster nor slower. It would maintain the time period and would be consistent. It plays a great deal in this particular value chain or the process. Again, for mobile edge computing, resilience, security, privacy, everything is matters a great deal over here. And edge computing framework can greatly reduce the complexity of interconnected systems. Also, I would say the reduced latency will drive an increase in various number of use cases at the industrial front. Yes, and while I was talking about the use cases over here, I would say that smart manufacturing is calling attention to large-scale automation, then transformation. The use cases being realized today will continue to evolve and expand in terms of the capabilities they can deliver. And now the manufacturers are actually exploring which of the use cases work best and which of the use cases would be influenced or driven by 5G. Over here in this slide, to make it a little easier, I would say the green circles over here show that the network feeder is critical for use cases. For example, RFID is one of the very common use cases now at this juncture. And how will 5G realize the goals of this use case? Especially when we are talking about the IoT devices, let's remember the battery life. That is, when we focus on the battery life of IoT devices, 5G plays an important role. Now, in the shop floor, what is happening is greater granularity in identifying faults at the factory floor and constant benchmarking of output against KPIs. This is also very much important while in the predictive maintenance of machines and health check of the machines. And in addition to all these use cases, 5G IoT network replacing fixed Ethernet connections at workstations would allow greater flexibility to make production line changes and reduce investment, which is one of the strategic priorities for the manufacturers at this point of time.
Thank you. What I'd like to emphasize, or I think my take-home message from this slide and the preceding slides, is that the use case that you're working on is going to be very significant in terms of your return on investment. It's not how much it costs, it's how much value it adds to your operations. And I think that, especially when we talk about chargeback and if you're looking at a dedicated edge or a distributed edge, for example, would be a telemedicine device, an implant that monitors your heart, for example. So but on a factory floor or in a port or in a retail environment, and in this case, smart manufacturing taking the lead, what you're going to do with it and what value you would get out of taking such an action is what matters. Thank you, Titley.
Yes, and in fact, if I may just jump in here, there is a question we got where it says, I'm responsible for a small scale factory. Can you tell me why I should use 5G? I would take a first step and then hand it over to Titley. And first of all, like David already mentioned, it very much depends on the use case. In case of the factory, it's a question of how far have you driven digitization? Are you using digital twin scenarios integrated in your manufacturing environment? Do you have applications which really require very low latency? Are your robots already communicating in an environment where this is critical? What are the scenarios you have now and the next steps you're planning? And are there alternatives, or in terms of those two things, permanent bandwidth on a high bandwidth and this low latency, that should really determine the case you're building for 5G. Titley?
Yes, Henning, and while we were talking about opportunities and the various use cases on 5G, I would definitely mention about coming across two of the classic examples or case studies. One is Factory 56 by Mercedes-Benz, which they have set up in collaboration with Telefonica and Ericsson, and how 5G is enabling superior and enhanced process efficiencies on the shop floor, for example, like data linking or product tracking. And then another of the use case, another of the case study, I would say, is real-time factory response test bed by Bosch, which has been set up by Worcestershire 5G Consortium. Now, coming to your question, why would a small or medium-scale factory choose or opt for 5G? Few of the, I would take it very short, few of the clear advantages for small and medium-sized businesses that demonstrate why it's being so eagerly anticipated is faster connections. So even if you are an omni-channel enterprise or a brick and mortar with an online presence, 5G will allow you to have a larger or faster web presence. And secondly, at the industrial front, you will have more IoT options. Looking at this juncture, like alarms, printers, etc., shipping trackers, or maybe inventory control rooms. So the bottom line being big utility savings and more efficient supply networks.
Thank you, Titley. So, in summary, especially in the manufacturing environment, the case for 5G, it's expensive if you do it, but it's expensive if you don't. So what are the reasons for 5G in a smart manufacturing or otherwise closed perimeter environment? We're going to improve security and reliability. We're going to design the network from the ground up to deliver ultra low latency services for those sensors and services that require low latency. For those services and sensors or cameras as it may be, we're going to deliver the very high throughput requirements such as virtual reality, AI, augmented reality as well, and a high number of users that can be supported. And a user traditionally has been a human being, but in the future, and even possible today, one of those users is going to be a machine. And so there could be an opportunity cost of inaction. And so one of the questions about small and medium business, inaction for the large enterprise is going to provide perhaps the opportunity for a small and medium business to eat your lunch because they're going to become more efficient. They're going to become more profitable, and that is a threat to the large industry. So small and medium business, absolutely, I want to echo, have a role in 5G and the private campus network. And what are the drawbacks of 5G? It's not, as Swati and I have mentioned, it's not globally available for private or even public use. It's a small number of countries. Most recently, a very, very large African country just said, you know what, we're not going to be looking at 5G at all this year. Maybe not next year. They're going to focus on their 4G network. That's a choice, but that's what governments and regulatory agencies do on behalf of their people. Hopefully that won't impact them and make them a global laggard and they can continue their leadership position on the continent. It is, as you know, I mentioned and Swati has mentioned, it's going to be more expensive due to network densification. It's complex, it's time consuming to deploy, consuming lots of resource hours. Wi-Fi is catching up, but it's still not going to allow the number of users without the interference that 5G can actually deliver. One thing that Henning brought to the table, I'm very interested in, is the network densification and the cost of silicon and devices. So Intel bringing units back home or construction or manufacturing back home, that's fantastic for those in the United States and perhaps, you know, more globally as well. We are having a problem as we talk about the expense of building networks out. Many people on this phone call probably are already aware there is a global shortage related to silicon of any kind. Any chips that you may need, they're going to be more expensive, at least for the short term. So thank you, Henning, for bringing that to the table. And maybe one day soon, we'll have those 5 nanometer chips that Intel promised 6 years ago. With that, I'm going to turn it over to you, Henning.
Yes, thank you. If we turn to the last slide. Yes, so we really want to round up the presentation of today on a balanced view about 5G with a set of questions we've put up to guide and help also to identify the right cases. Is it the right technology? Should I start building a business case? So there's some key considerations here. Like the first one is, do you need a comprehensive coverage for devices, sensors, or do you need a new kind of wireless backhaul for which you have ample alternatives already available today? Will the majority of the traffic actually stay within your own network, or will it be transmitted over the internet? Do you need fast latency or near low latency on open internet applications, or is it a local network which could be also built with other technology? What types of devices, features, and density are considered? The point which David just made in terms of density and close coverage areas, the amount of machines and devices which have to interact, over which distance do they have to interact? How big are the gaps you can cover with your existing networks and infrastructure? Is your upstream connection scalable and designed to cope with a high-speed campus network? You know, if you start implementing 5G on a private network, is your backbone actually coping with everything which will then be going back and forwards? Or does it need an upgrade too? Do you have the means and the capacity for that? Then for the global folks or the companies with global coverage, be it sales office, point of presence, or manufacturing plants, is 5G actually available in the country where your operation is planned or already happening? Both in terms of availability to the national operators, at least 2 incumbents, which David mentioned, or is there even a private network? Can you actually acquire a private spectrum, or is the only route via the 5G operator? Do you need your own network, or can you acquire? And does it make sense to build out and maintain and operate your own network, or is it maybe the easier route to go to a carrier? And one of the key questions is, once you've deployed your network, who will actually manage and be responsible for availability, security, and restoration, and who will guarantee these availabilities, these services to the users or the operational part? Will it be your own IT operation? Will it be a provider? What's the best mix there for the use case you require? And coming back to it, it all starts back with what are the applications you need running, not just today, but thinking 3-4 years out. With that, that concludes our presentation, and we're very open for questions. And Gillian, I've seen there's already another couple of questions coming up.
Thanks, Henning. Yes, we do have a few. The first one I want to cover is if I already have an IoT technology such as Sigfox or Zigbee in production, why and how can I move to 5G?
Swati, can you
Swati?
cover that one?
Yeah, absolutely. So in case of LoRaWAN or Sigfox or Zigbee, the problem is these have very, very low bandwidth. And also Sigfox and LoRaWAN cannot connect two-way. There is only one-way communication. So your sensor sends out the data to whichever location you're connecting to it. So in case you have a more dynamic environment, which is what we are seeing in the factory of tomorrow or smart manufacturing plants, this would not be an ideal use case. What 5G brings to the table is, as Titli mentioned, not just high bandwidth, it supports QoS because LoRa functions in an asynchronized fashion. So it would probably just put a critical message in queue while the action has to happen right then and there. And also, as we move to the future, the operations are going to be more and more data intensive. And for this, we would definitely need 5G. And how? Well, I'll hand it over to David.
Thank you, Swati. I think that question really hammers home the points that Titli and Henning were making about building your use case. There's so many different types of sensors. There's so many different types of devices out there that can be used to improve any particular operation, but you have to pick them wisely. And who is going to manage those sensors, the network, the devices, the security? These are this is complicated, and to a certain extent, especially when we're talking about the latest and greatest in mobile networks, 5G itself is only a couple of years old, and the latest version is less than a year old, and the next version is not even out yet, or the final version, as it may be, release 17 is coming out in June, July. That means that the expertise to run a distributed edge or dedicated edge network are going to be, at least in the short term, the purview of a mobile network operator or its parent company, the gigantic telco. Next question.
All right, thanks, guys. The next question, please talk about decentralized 5G telcos via blockchain.
That's a great question. Well, that's going to limit blockchain, as it may be, to where and a decentralized, where 5G is realistically available. And again, right now, that's going to be somewhat limited to dense urban areas. When you're talking a country the size of the United States or India or China, these are huge endeavors. Billions of dollars will need to be spent so that you can use blockchain wherever you might, and a distributed edge wherever you might be. But for now, I would say that's going to be limited to dense urban areas. There'll be some suburban or urban, metro, within a larger metropolitan area. May not be a very large population, 30 to 100,000 people, but there'll be 5G services available there. But again, as Swati had alluded to, some of the features that 5G is going to bring to the table right now are limited largely on the low and medium spectrum, is going to limit some of that which blockchain could actually take advantage of. So if there's a latency is a concern, that it may take, other than a few countries, which I could let Swati talk about that, that have implemented higher spectrum frequency, and it is a limited number of countries. That would be where I would expect to see blockchain be more viable. Swati, can you talk about where what few countries have deployed high spectrum frequencies?
Yeah, absolutely. So the recent most one is Japan, where Entity has launched. And there are a couple of countries in Europe which have tested the high range, high band spectrum, which goes into the millimeter wave range. But there are countries within Europe itself, since I was talking about it, which have where the operators have shown zero to no interest towards high band spectrum simply because it would need densification of network, and that would mean they would need a lot of financial resources. So it might not happen anytime soon, but as the economy and the adoption rate improves, I think the higher spectrum would definitely come into picture.
And you know, one thing, and it's a little out of scope, but and I do see some another question here about decentralization and telco control, which we'll answer in a second. There is in the background here, because of the improvements in mobile wireless broadband that 5G does bring to the table, whether it's the phone in your pocket or an IoT type device, that is, starting a war, if you will, between broadband operators and the mobile network operators. So one nice added advantage of 5G and its current implementation is a pricing that a consumer of any kind, whether it be an enterprise or a person, is going to be expected to pay. So in that respect, pricing is going to decrease because of the increased level of competition. But to answer this question, what does decentralization mean, as in telco losing control? Decentralization does not necessarily mean the telco can lose control, will lose control. What decentralized really refers to is how advanced is the 5G network available in a particular geographic area that a company or government agency can reliably deploy a IoT or other type service that's requiring edge where it needs to be closer. That does not mean the telco is losing control, though. In fact, when we talk about the automated vehicles, telco in the traditional central office POP, and that, by the way, broadband providers are also entering the edge space as well. That is going to actually allow them, as they've been doing their own network disaggregation of equipment and clearing out their central offices, their points of presence, freeing up space. They're going to be able to actually take advantage of that space and put your private network hardware stack into their central offices, which would reduce that latency time. So actually what we're seeing is not necessarily I would even characterize it as losing control, but a significant opportunity for carriers, whether they be a broadband provider, a tower operator, or a mobile network operator. They have the real estate and the backhaul network to make this happen. So that's how I would answer that question. Any other comments?
Yeah, maybe one comment from my side, and that's now without going too much into the regulatory debate. I actually don't see a one-to-one competition between private networks and the network operators, because many of the scenarios you just mentioned, for instance, car-to-car communication, require universal coverage. And that's something which is not profitable for the operator to do. the operators would like to really concentrate on the areas where they have urban population, where it's quite dense, to roll out there. In order to get a license, they will have some regulatory requirements to go beyond that and roll out in more rural areas as well. But in a manufacturing environment, certainly it makes a lot of sense for companies to build complementary networks alongside the carriers, because your area, it's not in the business case for the carrier, unless you want to pay them, to really build out the coverage you need for your business case, that they won't match one-to-one. So there always has to be a trade-off between what's publicly available or what's available through the operators and what you need for your own requirements.
You know, it's a good point, Henning. And, you know, most in the United States, most people think of 3, you know, maybe 4 mobile network operators. In reality, there's hundreds of mobile network operators in the United States because of the size of the country, and Canada for that matter, where no one wanted no Baby Bell or Canada's version of AT&T at that time, the Baby Bell system, wanted to build out in some of these areas where they didn't feel that return on investment was great enough. I think the one nice thing about Edge, building up on that point, and Edge services, contrary to popular belief, the hyperscalers and the system integrators aren't the only ones that know how to deploy a DevOps in a disaggregated environment. Carriers, in their own efforts, as I mentioned earlier, in disaggregation, actually have significant expertise now in DevOps environments and cloud computing as a operating model, not as a place. So it actually is good news for the industry overall, I think. I do see some another question and a clarification for blockchain, wanting to ask about banking and I just addressed the telco issue, I guess, and we could talk about another company called Rakuten. But we're run out of time, so maybe we'll address that question privately. Well, Titley, do you have, in 1 minute, can you describe what the impact to banking might be from 5G services?
I think the major implication in the banking sector would be the fastest customer experience. That is one of the, we haven't talked about the user experience or the customer experience. So I think the first thing that would be driving the banking sector by 5G would be the customer experience. And apart from that, a lot of reconciliations and the banking, the setting up a digitalized platform would be driven by 5G. But then again, I would say it is a futuristic approach. Like just an example, in India, how ICICI was the first bank to launch blockchain, but then how many of them are implementing it? Again, for 5G in banking I see as a futuristic approach.
Thank you, Titley. And my only add to that would be, in some countries, arguably not as developed as your average Western economy, if you will. I'll put that in quotes. They actually almost exclusively use their mobile phone, their citizens, that is, to do their banking. So that will happen. All right. And I think we're out of time, so.
We are. Thank you guys so much. Thanks for our attendees for joining. This does conclude our time today. As a reminder, you'll find the recording of this webinar at the same link you used to register. If you have any questions or would just like to get in touch, you can find us at www.isg-one.com. Thanks for joining.